tuku ingoa, ko ahau te kai whakahaere o Mātai. For those that don't know me, my name is Leigh Potter and I'm the Chief Operations Officer and co-founder of Mātai. I have a background in radiology, having studied medical imaging and then working around the world with medical imaging, predominantly in Tairawhiti though, and then spent over 10 years as the radiology service manager at the hospital here. I'm currently a project lead with Dr. Hari Kumar on the Tairawhiti Child Wellbeing Study. It's a real pleasure to be here. I've had a whirlwind couple of days with Dr. Makarena Dudley and Sir Richard Fall, and recently just returned from Uawa with our wonderful whānau up there, and I just want to acknowledge them and our whānau at Ngāti Porou for sharing some of the insights on Mati Wariwari over the last couple of days. So back to the Tairawhiti study. Our current knowledge, I just realised I don't know. Our current knowledge on paediatric physiology is very limited, hence children are often assumed to be tiny adults. In other words, we use knowledge gained in adult studies. Due to the lack of sufficient studies, we treat children reactively. This is how they usually present in radiology. And it's interesting, I just go back to a personal story where Jim Green, who was our CE at the time at the hospital, had said to us, how can we do things differently in secondary care and change that to be more preventative? And what Mātai has taught me, and one of the reasons why I came to Mātai, was how do we know what prevention looks like without medical research? So I take my hat off to all our researchers that are here over the next couple of days for their mahi and their passion to help us, for those of us in secondary care. Finally, existing data representative of our population here in Tairawhiti. We would like to address these issues in our study, so a child imaging study is a priority for us. We aim to understand physiology and be able to mimic them on a computer. So that will help us create predictive models, which I hope will help us drive prevention. The study is fully based in New Zealand with imaging at Mātai alongside our wonderful community, and we'll be using computer models developed at ABI. So in 2021, we had some wonderful tamariki who put their hands up to join us under the guidance of our public health physician at the time, Dr. Robert Green. We recruited 32 children from this region, aged between 7 and 12 years old. The challenge was to scan from head to toe, so some advanced sequences in there as well, in a reasonable time. Now, in the pilot study, that was about an hour and a half. Now, those of you that have children will know that that's quite an ask of a little person to keep still in an MRI machine. We have managed, since that pilot study, we've managed to get that scan time down to 1 hour with the help of our wonderful collaborators, GE Healthcare and Auckland Bioengineering Institute. Of the 32 children, we collected 22 full data sets. We learned that the use of Netflix or movies in our MRI scanner helped to keep the kids still. We had to have a rest in between the 1 hour scan, so we usually give them a little cookie and a juice and allow them to go to the toilet just to give them time to fidget. But quite often, I think the MRI techs at Mātai would agree that the feedback was the kids didn't like being interrupted while they were watching a movie. So that's definitely something you need to integrate into your study if you're doing MRI research, is having those Netflix movies for our tamariki. Imaging acquired was very useful, and Hari's going to go into this. Of the 23 interns, so we've got our summer interns are our own tamariki, our own tauira that are away at university studying in STEM. We gave them a project to bring our children back and to talk to them, so get some really good engagement going. And so they talked to them about how they contributed to the study, the findings that we had in hand at the time. We showed them some publications we wanted to do, so we wanted to seek their consent as well as their whānau, and the opportunity to ask questions around any of those publications. and then we told them about where we wanted to go next. Ethics is now being signed off to scan a larger cohort, so we're very excited about that, and we're hoping to start that next month. And we're also grateful for the opportunity that the Tairāwhiti studies presented in terms of actually introducing our children to STEM and technology like the advanced state-of-the-art MRI scanner that we have at Mātai. And we have some nice stories around that, particularly in our concussion study with the Rugby Boys High team from Gisborne Boys High, that I'm sure Josh will share with you. And finally, just a big thank you to our tamariki and our whānau that have brought their children in to participate in the study. We couldn't have done it without you. So I just want to send a big mihi to you all. Kia ora.
Thanks, Leigh. Kia ora. My name is Hari. I'm a clinical scientist. I'm also a healthcare to work on to support Mātai for their research projects. This study is a very very interesting experience for me. I'm a bioengineer by training. So I'm a scientist, but my training is in bioengineering. So this project brings together advanced imaging with some of the state-of-the-art computational models that's happening, that has been developed at Auckland Bioengineering Institute at Auckland, at the University of Auckland. So there's a big, like Leigh mentioned, there's a big gap in understanding human physiology for pediatric, the pediatric cohort, and this was identified by many of our collaborators. Their data and their models are tuned only for adults, and often they just have to use that when they treat children or understand the physiology of the children, and this kind of limits the usefulness of that model or the prediction or the capability. So that kind of as an underlying theme that all of our collaborators sort of told us, and then said, okay, this is a clear opportunity to kind of produce world-class data while working with the community, and that's kind of how this project started. So imaging children is not easy, and the team here has been excellent in kind of working together, because coming up with the correct protocol while keeping them not moving in the scanner, and so on and so forth. So the uniqueness of the study, like you see here in this slide, is that it is not a particular organ that we are interested in. So we used multiple sort of advanced sequences to scan the brain, which is more commonly sort of an application elsewhere, for example, UK, US. And there are many studies that just look at neurological neuroimaging, but there's no study out there that has scanned a child for across multiple organs. So in this particular study, we sort of used different state of standard clinical, but also sort of advanced sequences to scan the brain, the lungs, the cardiovascular, which is heart function and structure, abdomen, muscles, and bones. So we covered as much as possible. Of course, we couldn't we have to limit scan time, so we had to make a call on terms of what sequences to use and what organs to image. But we arrived, thanks to many collaborators and stakeholders, we came up with a nice sort of protocol. And then we used that, so we acquired data in multiple children of sufficient image quality, both for research and clinical or diagnostic purposes, and also primarily many of these images were designed, the image quality was acquired in a way that the computational modeling people, the collaborators were happy with, something they can use. So computational modeling, as you might see in future talks today and tomorrow, is an area that's quite ripe that can take the imaging data, but not just use standard radiological approaches to measure some of like volumetry or structure, texture mapping and so on, but it takes it a bit beyond that and goes into the area of what's called a digital twin. So it kind of helps you build atlases and goes and helps you make predictive modeling and go into predictive modeling. And bring data together and understand the physiology in a much more advanced manner. So that's kind of the usefulness of the approach of computational modeling. So we used these data and built these sort of computational models to help understand the population variability in not just, like I said, cardiovascular imaging or not just neuroimaging, but across the whole sort of organ. Muscles, bones, and also the images that you see here are from one of our data sets that we acquired here, where detailed structures of muscles, bones, lung models there, very advanced cardiovascular sort of computational models, and have been built from this particular data. So it started off, and then from there on, once you have these models, and you can start making predictions on what these data actually shows us using these sort of computational models. So we were also we kind of this study started as a bit of in an exploratory fashion. We're trying to say, oh, let's take a bunch of we have advanced sequences, let's play with this. But actually, it got quite a good feedback from reviewers around the world who had not just appreciated the sort of whole body modeling aspect of it, but also the link to that computational modeling. Ended up publishing this article. As you can see, it's a long, like 30 authors in there. So it has been a real fun challenge and also interesting journey for me. To play that, to keep the relationship with stakeholders, and because they all span across different sort of institutes, and they all have sort of very different expertise, bringing that together to this holistic vision of building these digital twin models in a very in a culturally appropriate manner, handling the data very carefully, storage of data, and so on and so forth, and then assembling them, and then coming up with this ideology of, okay, where are we heading towards, and that has been a really interesting scientific journey for me, and that has led to further refinement of sequences for the next stage or next phase of this study. So that's been the experience from my viewpoint of working with MRI as a bioengineer and also a GE healthcare clinical scientist on this particular project. Thank you.
So thanks to Leigh and Hari. The Tairāwhiti study is really just an amazing project. It's bringing cutting-edge imaging together with the amazing computational modelling expertise of Auckland Bioengineering Institute, and doing that alongside our community with its unique demographic. It's just probably one of our dream projects, and I'm very excited by that project. And so I'm just going to talk a little bit about, first of all, actually, what I'm going to do is a couple of admin-based things, and then I'm going to introduce one of our amazing research fellows, Dr. Miriam Taby. But just first up, we've realised we have not been giving our speakers our wonderful tote bags here, Mātai tote bags. So if all of our speakers in this break come to the back of the stage, because we've got one of these bags as well as a Mātai t-shirt for you. And I also just earlier made a bit of a mistake there on the program. The program is correct. We've got Dr. Makarena Dudley at 3:30 today, and Dr. Catherine Morgan is speaking tomorrow. I had it wrong on my sheet. So Makarena is today. So I'd like to introduce Dr. Miriam Taby. So Miriam is funded by the Hugh Green Foundation, who has been a foundation that's been absolutely instrumental to Mātai. The Hugh Green Foundation has funded Miriam as well as some internships for Mātai. And Miriam is going to be organising the interactive lunch session with the Gisborne High School students as well as some of our university students. And I just want to mention about Miriam. She's working on both our methamphetamine recovery project as well as our concussion project, which the Hugh Green Foundation also funds alongside our prostate cancer pathway as well. So just a big shout out to Hugh Green Foundation for that. This is one of your stars right here. So Miriam's just going to give some sort of an overview of how that session will work. So introducing Miriam Taby.
Kia ora, everyone. So as Sam mentioned, I'm just going to give you a little bit of introduction and information about what's happening outside. So we're having this interactive lunch session. So there are 3 different activities. One is the students poster session. So we're having 2 groups of students, high school students and university students. So, and also we're having 2 different stalls from local companies from Gisborne, Tonui Lab and House of Science. So they're providing engaging and interactive science session. And so for the poster sessions, so students and the high school students having the, they made a poster with the theme of how will science and technology shape the future? And also the master and PhD students will talk about their ongoing research projects. So we selected 6 judges from our wonderful, amazing speakers, and they will review these posters, and also they just like review them based on the clarity of the message of the poster or the innovation and different areas. So we will the winners will be awarded on Friday evening, and there will be 6 winners in the university level and 3 in the high school level. Apart from that, we also have the People's Choice Award. So for that one, we want to encourage our communities. Please have a look at the students' poster, talk to students, ask them questions, and then there is a voting box in the lobby, so you can just write whatever poster you liked more, and then we will also provide some award, one special award for the People's Choice Award. And also, yeah, I think that's all thing that I need to mention. So with that, I would like to invite you guys, please join our interactive lunch session outside in the lobby. Thank you.